The topic that we'll discuss is composite function. Let us see the definition of composite function. Suppose we have two functions f and g. F is from a to b and g is from b to c, such that range of f is contained in domain of g. Then we will have a function from a to c. This is how we denote that function, and that function is defined as this. Okay, for all x in a, and this function is only called a composite function of f and g. And we must note one thing, that this symbol is read as f composite g. Now let us see an example. Here I have taken three sets, a, b and c. F is defined from a to b as this, f of x equal to x square, and g is defined from b to c as this, where gx equal to x plus 1. So like in definition, we had taken two functions f and g. F was from a to b and g was from b to c. So then it said that if these two functions are such a way that range of f is contained in domain of g, then we'll have a function this f composite g from a to c. So here in our example, clearly our function f is from a to b and g is from b to c, and this condition is also satisfied, that range of f is contained in domain of g, because here range of f is this is the range of f, and domain of g is whole of b, and clearly the range of f is contained in domain of g. Therefore we will have a function from a to c which will be defined in this manner, and this function is only called the composite function of f and g, and it is read as f composite g, f composite g. So here f composite g of 1, okay, will be equal to g of f of 1 by the definition. Okay, like see the definition here. So f of 1 means here f of 1 is 1. So in place of f of 1, what we get? 1. And thereafter g of 1. So we know g of 1 is 2. So here we get 2. So therefore f composite g of 1 is equal to 2. f composite g of 2 will be g of f of 2, and f of 2, here f of 2 is 4. So we get g of 4, and g of 4 is 5. So we get 5. Then f composite g of 3. So that would be equal to g of f of 3, and f of 3 is 9. f of 3 is 9. So g of 9 will be 10. Let us see a few examples. Here let f be a function from this set to this, and we have another function g which is from this set to this set. Here if you note that these two are same. Yes, so obviously range of f will be contained in domain of G. In fact, here we have something like this. F is from A to B, where A is this set and B is here 1 to 5 and B 1 to 5 and C is 1 comma 3. So, and we see that range of F is contained in domain of G. So we will have a function from A to C. Okay, that is called F composite G from A to C. So here in place of A we have this set 1 comma 3 4. So we'll have this, and in place of C we have 1 comma 3. So we will have F composite G, a function from set A to C. Here F is given from A to B and G is given from B to C, and this is how these functions are defined. So if you take 1 here, then that 1 is getting associated to, that means f of 1 is equal to 2, f of 3 is equal to 5, f of 4 is equal to 1. Now here for g of 1 equal to 3, g of 2 equal to 3, g of 5 equal to 1. We need to write f composite g. So we have already seen that f composite g will be a function from set A to C, that is from set this to this. Okay, and so let's see the solution. Given f is this, okay, from here, and g is given to us, this is from here. Okay, now f is defined as this, that means f of 1 is equal to 2, f of 3 equal to 5, f of 4 equal to 1, and g of 1 equal to 3, g of 2 equal to 3, g of 5 equal to 1. We need to write f composite g. Then f composite g of 1 will be equal to g of f of 1 by the definition of composite function. So f of 1, from here see f of 1 is 2, so we got 2 over here. Then g of 2, here check g of 2 is 3, so we got 3. Then f composite g of 3, so it would be g of f of 3. f of 3 is 5, so g of 5 equal to 1 because g of 5 is 1. Then f composite g of 4, so g of f of 4, f of 4 is 1, so g of 1 will be 3, g of 1 will be 3. So therefore we got f composite g as this. Okay, so f composite g is a function from this set to this set. Okay, so we will write the elements for this in order pairs. So 1 comma 3, because 1 is associated to 3, 1 is related to 3, 3 comma 1 because 3 is related to 1, 4 comma 3 because this 4 is related to 3. So we got the composite function. We can see the diagram also. Now the last example. Here we have got two functions, here f and g. F is defined as f of x equal to x square minus 1, and g is defined as g of x is square root of x. We need to find f composite g composite f F composite G, F composite F, G composite G. We have to find how this composite function will be defined. Okay, the general rule for this G composite F, F composite G, F composite of F, G composite of G. So here G composite F of X means F of G of X. Now by the definition of G of X, this is equal to square root X. So here we got square root X. Region is this. Then we have F of root X. So let's see how F is defined. Here suppose we have X, then output is X square minus 1. So here we have X, then we have X square minus 1. So here we have root X. So by the definition of function, the output will be root X whole square minus 1. Solve it, we'll get X minus 1. Then F composite G of X. This would be equal to G of F of X. F of X by definition it is X square minus 1. So we got X square minus 1. And then G of X square minus 1. So here definition of Gx is root X. So G of X square minus 1 will be root of this whole. Next, F composite F of X. So that means F of X. So F of X is X square minus 1. And F of X square minus 1, again by the definition of F, this will get whole square of this minus 1. And then we'll solve it, we'll get x to the power 4 minus 2x square. Then G of G composite G. So here G composite G of X will be G of X. So G of X is square root of X, and again we'll apply the definition of G, then we get root of this square root. Okay, so when we'll solve, we'll get x to the power 1 by 4.